السلام عليكم أصدقاء الطلاب. Welcome to Chemistry Online with Mr. Ahmed Soliman. Today we are going to start lesson 3 of our chapter 4, distinguishing among atoms. As you know, the atom is composed of 3 types of subatomic particles. So they are similar in their components, but they are not exactly the same for all substances, or we can say all elements. Look at these dogs. All of them are dogs, but they are not exactly the same. Each one has its own shape. Yes, but all of them are dogs. They have a variety. Yes, the same as the atoms. All atoms have the same components, the 3 subatomic particles. Also, they have the same structure, but they are not the same in their numbers of each of these components, or I mean electrons, protons, and neutrons. To identify the atom, we have two things, something called atomic number, something called mass number. You studied that before, but I will remind you about them. These two variables make the atom different from the other atom, especially atomic number. But we have to know what's different between atomic number and mass number. First, atomic number of the element is the number of protons in the nucleus of an atom, of the element. Look, if you have an atom like sodium, Na, it has 11 atomic number and it has 23 mass number. So you have to know atomic number is written like subscript here, and the mass number is written as superscript like this. This is the atomic number and this is the mass number. What does it mean for each of them? 11 means, atomic number means number of protons. It means sodium has, look, if we draw the nucleus here, we have 11 protons positive inside the nucleus of sodium. Also, you have to know the number of atomic number is the same as electron as well. So 11 means number of protons, or we can say number of electron. I'll draw it afterward. But look at the mass number. Mass number means number of the summation of number of protons and neutrons. What does it mean? It means if the number of protons are 11, that means mass number 23 means 11 plus protons are 11, and the neutrons, how many to make the summation 23? 12. It means we have here 12 neutrons. Neutrons in the nucleus, which are neutral like this, so we have 12 neutrons inside the nucleus of sodium atom. What about electrons? Electrons are in the levels around the nucleus. In the levels, how many electrons I said? 11, because the number of electrons equal the number of protons. They are 11. So electrons are located here, 1, 2, then 3, 4, 5, 6, 7, 8, 9, 10, then 11. They are 11 electrons, the same as the number of protons, as I said. And I want to remind you, because number of protons must be equal number of electrons, because the atom is electrically neutral. We said that before. Okay, but why I put the electrons only 2 here in the first level and 8 only in the second level and the last one in the third level? Here 2, here 8 and here 1. Why we put that? Because the first level cannot carry more than 2 electrons, and the second one cannot carry more than 8 electrons. Maximum number of electrons can be found in the second level, and the third level can carry up to 18. Well, we need only to put 1 electron, so we put it in the third level like this. This is the atom of sodium, so we can identify how many protons, how many neutrons, and how many electrons by using two things. What are they? Atomic number and mass number. And we got the meaning of each. For any atom we can do that. So what mean by atomic number now? Atomic number is the number of protons in the nucleus. Don't say and it's number of electrons as well. Although it's a number of electrons, yes, but as we will study inshallah, you will know that number of electrons can be varied because the atom can lose electron or more or gain electron or more to become a positive ion or negative ion. We will study that inshallah. But number of electrons can change from number to number because of losing or gaining. The protons cannot change because they are in the nucleus. Okay, so it's better, more accurate to say atomic number is the number of protons in the nucleus of the atom of the element. Atomic number is the identity of the element. What does it mean? It means you can identify the element by using the atomic number. يعني whenever I say atomic number 8, you have to say it's oxygen. Atomic number 9, it means it's fluorine. Atomic number 17, it means it's chlorine, and so on. So the atomic number is the identity of the element. You can identify the element from the atomic number. It means each element has its own atomic number. Each element. Okay, this is the atomic number. We have some examples of atomic number here and symbols of each of some elements: hydrogen H, helium He, lithium Li, and so on. Some elements and some symbols of them. Atomic number, whether 1, 2, 3, 4, whatever, up to 10. Each one has its own atomic number, and the number of the atomic number is the same as the proton. Look, the same for everyone. Okay, the atomic number is the same number of protons, and also for electrons, as I said. Okay, if they are not changing into ions, if it's still atom, if the atom is still atom neutral without changing into ions, it means the proton will be the same as electron, as you see here and there. Okay, طيب, if you want to know the mass number, not every time is the double of the atomic number. Okay, sometimes like this, helium 2 atomic number, mass number is 4, double. But not every time. Look at lithium 3, but mass number is 7. I remind you, mass number is the number of protons plus neutrons, but atomic number is the number of protons only. So the change happens here because of the number of mass number is the number of neutrons. Change it from one atom to another atom. I mean, again, not every time protons equal neutrons in the atom, in the nucleus of the atom. Not every time like this. I can give you an example here. Look, I give you example here. Helium has 2 atomic number and 4 mass number. It means the protons equal 2, neutrons equal here protons plus neutrons. If the protons are 2, neutrons 2 as well. Okay, or you can subtract mass number and atomic number, you will get number of neutrons. Number of neutrons 4 minus 2, 2. You can say number of neutrons equal number of protons, but not every time. Look at lithium, atomic number is 3, but mass number is 7. Protons equal 3. Neutrons, very quickly subtract. 7 minus 3 is 4. Or we can say number of neutrons not equal number of protons. Okay, and so on. Not every time they are doubled, or the atomic number and the mass number, not double the atomic number, and not every time protons equal neutrons, sometimes and sometimes not. This is the mass number. For this reason, we have something called isotope. I will tell you what is meant by isotope afterward. So atomic number is the number of protons, and as I said, if it's electrically neutral, we can say it's atomic number is the same number of electrons as well. Atomic number, for example, nitrogen equals 7. We need to answer this. How many protons and electrons are in the neutral nitrogen atom? If nitrogen has 7 atomic number, it means protons equal 7. And also electron equal 7. Why the same? Because he said neutral nitrogen, not ion. Neutral nitrogen atom, not ion. Okay? We cannot find the number of neutrons here because he didn't give me the mass number. By the way, I can give it to you. If the mass number is 14, what does it mean? It means number of neutrons equal, make subtraction please, 14 minus 7 equal 7. So we can get the number of neutrons if we have the mass number. This is a very quick exercise to know how to get the number of electrons and the protons from the atomic number. Now, mass number. I think I explained mass number is the total or summation of number of protons and the number of neutrons in the atom. Okay, this is the mass number. Mass number, as you know, can identify the number of protons plus neutrons. If you have the atomic number, which is the number of protons only, I think by subtraction you can get the number of neutrons. After that, you can determine the number of neutrons, and by using atomic number and the mass number, you can identify the 3 subatomic particles, or we can say that we can determine the composition of the atom. I told you if you want to calculate the number of neutrons, you can make subtraction between mass number and the atomic number. If you want to represent the mass number, you can use the shorthand notation. What is the shorthand notation? To represent the composition of the atom. It's easy, like this. This is a shorthand notation. Look. Au is the symbol for gold. Gold element. The atomic number is written like subscript. Okay, subscript like this. And the mass number is written like superscript like this. Look, superscript for mass number like this. If you do the element like this, it means this is a shorthand notation. I did some of them and I will do another now to know what I mean. Nitrogen, the symbol is N, has atomic number 7. This is subscript. And has mass number 14. This is superscript. So we have shorthand notation for nitrogen. Carbon has 6 atomic number and 12 mass number. This is a shorthand notation for carbon to represent the carbon, and so on. Sodium, Na, has 11 atomic number, 23 mass number. Okay, this is a shorthand notation for sodium and as well. Okay, this is shorthand notation to represent the composition of the atom. You can also refer to atoms by using mass number only mass number without atomic number. How? Another method. You can use this shorthand notation and maybe written like this. You can write not the symbol but the name of the element and the hyphen here, then write the mass number, not the atomic number, the mass number only, the mass number only. You can represent the element by this method as well. Okay, so we have two methods to represent the atom. Okay, here exercise of determining the composition of an atom. If you have like these atoms, beryllium Be49, neon Ne1020, sodium Na1123. How many protons, how many electrons, and how many neutrons in each? So easy. Number of protons are the same as atomic number. So number of protons here 4. And also because all of them are atoms, neutral atoms, so number of protons equal 4 and the number of electrons equal 4. Here number of protons equal 10, electrons 10. Here protons equal 11 and electrons equal 11. What about neutron? Make subtraction, so easy. Neutrons here 9 minus 4 5, neutrons here 20 minus 10 10, neutrons here 23 minus 11 12. So we got all of the components of each element or atoms in this exercise. Now we have something called isotopes. How do isotopes of an element differ? What's meant by isotopes? Look, for example, we have an element called neon. Look at neon here. This is neon 20. What does it mean, this? This is not shorthand notation. It's another method for representing the element. The name of the element and the mass number. So 20 is the mass number. Neon, 20 means the mass number of neon. But we have neon 21. It means neon has another form of the element or the atom with 21 mass number. And also we have neon 22. So we have 3 forms of the same element neon. Each one has its own mass number. Okay, what does it mean? It means neon has 10 protons each time. Protons doesn't change. The number of protons doesn't change. Okay, but the change here is in the neutron. Neutron, also electron doesn't change, I know, but I don't know it now. Okay, because all of them not ions, they are a neutral atom. But listen, what change happens here? Change happens in the neutron every time. Here, if it's 20 mass number, protons plus neutrons, protons plus neutrons, protons plus neutrons. Each time proton is 10, 10, 10, 10. So the change happens in the neutrons every time. How many neutrons here? 10 plus 10 to get 20. 10 plus 11 to get 21. 10 plus 12 to get 22. So the change happens in the number of neutrons. Here 10, here 11, here 12. For the same element? Yes, for the same element. That means the same element can differ in the number of neutrons? Yes. And we have the same element, but differ in the neutrons? Yes. What does it mean? It means isotopes. So what's meant by isotopes? Isotopes are different forms of the same element, equal in their atomic number or number of protons, but different in their number of neutrons only. This is the meaning of isotopes. As I said, all have the same number of protons, which is 10. All of them have the number of electrons, the same, 10, but they differ in their number of what? Of neutrons, as I said. For this reason, they are isotopes to each other. So what's meant by isotope? Isotopes are atoms that have the same number of protons, but different numbers of neutrons. This is the meaning of isotope. Writing chemical symbols of isotopes. Look, if you have diamonds, diamonds are naturally occurring from elemental carbon. Diamond is a type of carbon. We have two stable isotopes of this carbon. One called the carbon 12, it means has mass number 12, and the carbon 13 means has a mass number 13. We need to write the symbol of each isotope using superscript and subscript to represent the mass number and the atomic number. How? It's easy. For this, we can write carbon like this. Carbon has 6 atomic number and 12 mass number. Carbon here has the same 6 atomic number because 6 is the number of protons, and 13 mass number because it's written here 13. So we wrote the subscript and superscript for each one. So we have different forms of the same element, or we can say isotopes of carbon. So the steps: first, you have to identify the symbol, then identify the atomic number which is written as subscript, then write the mass number as superscript, okay, which is a mass number, then write the symbol like this and like this, as I wrote before. We got the meaning of atomic number and the mass number, but we have something called the atomic mass, not mass number. What does it mean, and how do you calculate the atomic mass of an element? What's the difference between atomic mass and the mass number? They are not the same. Masses of even the largest atom is incredibly small, very small. Any mass, if you get the heaviest atom, you will see that it's very, very, very small mass. It has very small mass. How can we determine the mass of the atom? It's very small. The scientists used a device called a spectrometer to identify the mass of the atom. But it's very, very small, as I said. The mass, for example, of fluorine, look, 3.155 times 10 to the negative 23 gram. Very, 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 very tiny, the mass. How can we deal with these very small numbers for all elements? It's difficult. The science tried to find a method to deal with them, not by using the actual masses of them because it's very small. We can refer to this atom and make this atom like reference isotope because it's difficult to use it practically because it's very small, as I said. They choose carbon 612, or we can say carbon 12. This element is the reference isotope to measure other atoms by using it. This carbon 12 is the reference isotope. This isotope carbon assigned as atomic mass unit, as unit بقت عامله زي unit. What's meant by atomic mass unit? Atomic mass unit, or we can use initials AMU, is defined as 1/12 of the mass of carbon 12 atom. Look, remember the carbon here. Carbon 12 means the nucleus has, look, if we write carbon like this, 612 to remember the atomic number. How many protons? 6. How many neutrons? 6. Subtraction. Okay? And leave the electron now. They are 6, but leave them now. Okay? Now I need the nucleus because the atomic mass unit is using the mass which concentrate in the nucleus. Okay, how many individuals in the nucleus here? 6 protons and 6 neutrons. It means 12 individuals. Yes? Imagine with me, this is the nucleus of carbon. It has 12 individuals. 1, 2, 3, 4, 5, 6 protons. 7, 8, 9, 10, 11, 12. 6, another 6 neutrons. And as you know, the mass of protons equal the mass of neutrons, so we have 12 individuals. Each one is equal to the mass of proton or neutron because they are equal in their masses. 12 individuals equal in their masses. So if you want to identify any other atom, unknown atom, okay, if you have unknown atom here and has a nucleus, if you want to measure how many inside this atom, measure it or compare it by using this reference atom, which is its mass is 1 over 12 of the mass of carbon. Carbon has 12 individuals. Each one of these equal 1 over 12, 1 over 12 of the mass of the total mass of carbon. So 1 over 12 of mass of carbon means 1 of 12 of mass of carbon means only one individual of this, which called AMU or atomic mass unit. Again, 1 of 12 of the mass of carbon indicates only one individual of these 12 individuals. Yes, this is the AMU or atomic mass unit. It means if you have an atom here and I told you it's 24 AMU, it means it has 24 of these individuals. If you are using this method to measure the mass, much easier to use the actual masses of those atoms. Yes. So atomic mass unit is defined as 1/12 of the mass of the whole carbon atom. Carbon 12 atom has 6 protons, as I said, and 6 neutrons. Okay, so its mass is 12 AMU because it has 12 individuals. Okay, as I said, so it's 12 AMU. Other elements can be measured as this method by using this reference isotope. All elements have isotopes. Most of them in nature, most of the elements occur as a mixture of 2 or more isotopes. Like chlorine. Chlorine is found like 1734, chlorine 1735, or 35 point something, and so on. Yani it's more than one isotope. Most of the elements like this. But we need to represent only one value for the mass number. Look at the mass number here. 34, 35, we identify one number only. How can we do that? I know what you are going to say. We can take the average of those numbers. 34 plus 35 divided by 2, you will get the average. Yes, it's correct in math, but it's incorrect in chemistry. Why? Because one of them is most abundant than other. Yani can be found in nature mostly than other. Or we can say, we can find, for example, chlorine 1735 in 95% in our nature. But only 5% of chlorine 1734 can be found. So we cannot put this value for both of them as mixture because one of them is most abundant than the other. So we have to make another method. Look at this table. Hydrogen has 3 isotopes. Each one has its own abundance. Look, one hydrogen has mass number 1.0078 mass number, its mass number, and it's found by 99.9% about like this. But H12, this H1 1, 1 2 and 1 3. 1 2, if the mass number is 2, it's found by 0.015 only, very small percent. And the third form of this, or the third isotope, which is mass number 3, has negligible percent, not found a lot. The same for helium, one of them most abundant the other. For carbon, one of them like this most abundant can be found more than the other. Oxygen has one of the three forms of isotopes more abundant than others, and so on for chlorine and other elements. So we have to find the method. Look at this chlorine, 1735 and 1737, two isotopes like this. For example, how can we deal with these isotopes of chlorine? Look, if you have like this and you made average, as I said, by summation of these two mass numbers divided by 2, you will get number like this. This is like called average atomic mass. Average atomic mass. This is average atomic mass, but we need to find another method to get the average atomic mass by our own method in chemistry. Look at this. Chlorine 35 accounts by 75% more abundant than the other, but chlorine 37 maybe 24 only, about 24 or 25%. If you want to get the weighted average mass of chlorine, you can find the total numbers of protons here for the 4 forms here, and the total number of neutrons here. Protons and the neutrons gives you the mass of nuclei. Divided by 4 forms, you will get the weighted average, but this method is not accurate. Atomic mass of the element is the same as weighted average of the mass of this atom naturally occurring, but we need to find the method to refers to the abundance of this isotope. Look at this method and you will see how can we deal with that case. If we have carbon, and carbon has 2 stable isotopes, one carbon 12 and the other carbon 13. Carbon 12 has a natural abundance of 98.89%, and carbon 13 has abundance 1.11%. You will do these steps with me. First, you will multiply the mass, which is 12 here, times the percent, but after changing the percent into numbers. 98.89%, change it into number, means divided by 100 to make it number. Okay, it means 98.89 divided by 100. Okay, means 0.9889, like this. We change the percent into numbers. Multiply this number by the number of the mass here. Then do the same for the other isotope. Multiply the mass times the percent after changing into numbers. Okay, which will be 0.0111, like this. Okay, look. Then add the two values you got. Add them. After adding them, you will get the value, which is atomic mass, not mass number. The atomic mass of the carbon, 12.011 AMU. This is the atomic mass. Look, notice that the value you got must be very close to one of the masses here, and must be close to the most abundant one. Look, 12.01, close to 12 or close to 13? Close to 12. And 12 is the most abundant form or isotope. Yes, must be like this. If you find the result close to the least abundant, it's wrong. Listen to this. Okay. Look at this example. Element X has two naturally occurring isotopes. One of them has mass 10.012 mu, and the percent is 19.91%. The other isotope, it has mass 11.009, okay, and its percent is 80.09%. Calculate the atomic mass of this element. It's so easy. Multiply this times this after changing the percent into numbers, and multiply this to this after changing the percent into numbers, then add both of them. You will get the atomic mass, and the atomic mass must be close to, very close to, the most abundant one, which is 11, not 10. Why? Because 11 has 80%, about 80%. Look at the answer and you will see the result must be close to 11, not 10. Look at the calculation here. We multiply the mass times the percent, the mass times the percent, then we added both of them. You got 10.8. 10.8 close to 10 or close to 11? Close to 11. 10.8 close to 11. So it's close to the most abundant one. You got that? Why is the atomic mass of an element usually not a whole number? Yes, it's not a whole number every time. It has decimals. Why? Because when we are calculating it, you are finding the weighted average of the mass. Weighted average, it's average, natural occurring. So must be not a whole number. This is the end of our lesson today. I hope to understand everything. Thank you, Shabab.